This discussion will introduce the chain rule for differentiation. The chain rule is used when a function is a composition of two functions. If y equals f composed of g, then the derivative of y is equal to the derivative of f composed of g times g prime, the derivative of g. So, we have the chain rule here. If the y is a composition of f and g, y prime equals the derivative of f evaluated at g times the derivative of g. Let's see if we can apply the rule. Let's consider a function like y equals x squared plus 3 to the 8. So that's a nice big, if we were to expand that and turn it into a polynomial so that we could use the power rule term by term, we'd have a lot of multiplication to do. Lucky for us, we have the chain rule. We're going to recognize that this function is a composition function. If we let f of x be x to the 8, and we let g of x equal x squared plus 3, we see that f composed of g would equal f is the input to the 8th power, but the input is going to be g, and g is x squared plus 3, so x squared plus 3 raised to the 8th. So our y function is a composition function. Now we're going to apply the chain rule. The chain rule says that the derivative of this composition equals the derivative of f evaluated at g times the derivative of g. Okay, well obviously we need the derivative of f, we need the derivative of g. Well, the derivative of f, looking back up here, is 8x to the 7th. The derivative of g prime, is just 2x. But we don't need just the derivative of f, we need the derivative of f evaluated at g. So let's get the derivative of f evaluated at g, composed of the g function, in other words. So we have 8 times whatever g is raised to the 7th. Well, g, remember, was x squared plus 3. So it's x squared plus 3. So our derivative takes this, the derivative of f evaluated at g, and multiplies it by g prime, which was just 2x. Simplifying, we see that 2x times 8 is 16x times x squared plus 3 to the 7. And that's an application of the chain rule. Let's do that same problem, but kind of do it a different way. Most students get a little lost in the identifying, well, what's the composition function, and who's composed of who, and applying the chain rule in this way sometimes loses students. So let's look at it another way that might help you. Let's consider that same function, y equals x squared plus 3 to the 8. Sometimes it's helpful for students just to think of this as sort of the inside, and then this is the outside. And what you do is you differentiate the outside, you bring the 8 out front like you normally do with the power rule. Don't we normally bring the exponent out front? And then just copy this down. This is like our x that's normally there. If we had x to the 8, we would bring the 8 out front and then just write down our x. And then we subtract 1 from the 8 and get 7. And then we go times the derivative of this inside function, which is the function that was the input. So the derivative of this is just 2x. And see how quickly we get to the same derivative? Simplifying 2x times 8 is 16x. And so we have 16x times x squared plus 3 to the 7.